So in this video we're going to discuss about the police quantum number. So as we have in the previous video we have discussed the shape of the orbitals. So now let's see the police quantum number. So this number was given by von Pauli in 1925, right? After that what he said that according to this quantum number, what he said, according to this statement, in an orbit of an atom, no electron has the same set of quantum numbers. Fine. Now, what actually he said, how he said this concept, how he has given this concept. He said, according to this statement, in an orbit, no two electron can have a set of four quantum numbers. For suppose if we have here, I am drawing the shell. This is the nucleus, this is the shell, and here we have two electrons, 1 2, and then again here we have 1 2 1 2 1 2 1 2. Now this is the basically the shell which I have drawn, in which we have the like this electron. So now here you can see this pair of electron is now here, it is known as orbitals. It is known as orbitals. Fine. After that, this was given. Let me erase this. Yeah. After that, why he actually said this? He just put the concept that if here we have, let me tell you the example. Now, before going through that, let me tell you, the police quantum number basically tell us about what. This police quantum number tell us about the spinning of electron, how actually spin electron is spinning, right? Spinning the electron. After that, like how is electron spin like in this way. Electron spin in this way means one clockwise and one anti-clockwise in two directions. One in clockwise and second in anti-clockwise. Why this electron revolving clockwise and anti-clockwise? So let me tell you about this. Okay, why electron revolving clockwise and anti-clockwise? So here you may take the concept of that. Yeah. So suppose if here we have one nucleus and two electrons are present. Fine. Now here, for suppose this is the K shell, we all know K shell, and here the principal number in K shell is n. N is equal to 1. So now we have to find out that how these four quantum set are different or not same from each other, right? So for suppose if we talk about the quantum number, we make the table. Here we're gonna write the quantum number. Then here we're gonna write the electron 1. This is the electron 1. This is the electron 2. Here we're gonna write the electron 2. Fine. So if we do talk about here, so what actually will happen? First of all, we have the N, L, M, and S. These are the four quantum numbers. One is principal, azimuthal, magnetic, spin. Fine. After that, here I took this one shell. So in this, the principal quantum number N is equal to 1 and L. Now to determine that how we should find the L, we have one formula, that is L is equal to N minus 1. L is equal to N minus 1, so means N we have what? 1 minus 1 is equal to 0. So here azimuthal quantum number is 0. After that, here if we do talk about the M, so to determine the M we have also one formula, that is plus 1 comma 0 comma minus 1. So here first of all what? Here we have plus 1, that is what? That is 0, then 0, then minus 1, 0. So total magnetic quantum number is also 0. And if I do talk about here spin, so that is basically, yeah, spin, so that is 1 upon 2, means this is revolving in the, in what, in the clockwise direction. And clockwise direction, fine. If I do talk about here about what, if I do talk about here E2 electron, so here for the principal quantum number same 0, magnetic quantum number same 0, oh sorry, azimuthal, then magnetic 0, then here for the spin that will be changed, that will be the minus 1 upon 2. Why? Means this is revolving the anti-clockwise direction, revolving the anti-clockwise direction, fine. So now I want to give you the concept of clockwise and anti-clockwise. So let me erase this. Okay. So here for suppose if you can see that when we have what here, if we have one nucleus and electron is revolving around the, fine, electron is revolving around the nucleus, these are two electrons. So now how these both electrons will revolve means in these both electrons, for suppose here we have two electrons, 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 fine. These both electron how they will revolve, these both electron will put the repulsive force. Why they both put? Because both have negative charge और दोनों के पास क्या है, दोनों के पास हमारे पास क्या है, नेगेटिव चार्ज है, बोथ हैव नेगेटिव चार्ज, तो दोनों क्या करेंगे, एक दूसरे को रिपल करेंगे, रिपल्सिव फोर्स. सो व्हेन द रिपल्सिव फोर्स आर done, so one electron revolve in this direction, another will revolve in this direction, sorry, yeah, so these both, this is revolving the clockwise direction, and for that we have given plus 1 upon 2, and this is revolving in anti-clockwise direction, and we have given as minus 1 upon 2. Fine, on the basis of here Pauli's exclusion principle, just only tell us about the spinning of electron, how electron is actually spinning in the orbits. Fine, after that here what we have, yeah, here again I'm gonna give you another example, so it will be the damn clear to you guys. Okay, so let me write here, yeah. Yeah. For suppose here we have what? Here I am taking the sodium, and sodium atomic number is 11, as you all know, right? So here I took the sodium. So sodium electronic configuration is 1s2, 2s2, 2p6, then 3s2. 3s2. This is the configuration. Now how we will do the configuration? So count this 2, 2, 4, 4 plus 6, 10, 10 plus, sorry, here we will be having 1. 10 plus 1, 11. 11 is complete, right? After that, now here we're gonna put the orbitals, like how orbitals revolve. So in 1s2, how orbitals revolve, these orbitals will revolve like this. One in this direction and other in this direction, fine. In the 2s2 same, one in this, one is this. 3, now 2p6, now here as you can see 6, we can, it will again split into 3 more. that is Px, Py, Pz, according to Hund's law, here we have 1, 1, 1, then in the last we have 1, 1. To complete this we have given, otherwise if something is complete, so we can remove this 1 2. So we can remove this 1 2 if our one thing is complete. We only put the 1. Fine. But here to complete this we will give the 2 because 2 electrons maximum we have what? Maximum we have 2 electrons. Fine. So 4 again 2, 5, 6, 7, 8, 9, 10, 11. Here we're gonna put 1 1 because 11 are complete. But if you guys are putting 1 1 in this, so this might be known that in the 1 1 there should be in the same direction. As you can see, I put in the same direction, that is clockwise direction. All should be clockwise and either all should be in the anti-clockwise direction. Fine. Hopefully you get something new from this Pauli's exclusive principle. So in the next video we're gonna discuss about the UFPA principle. So bye bye.